of the more unexplored and unknown aspects of climate change are urban heat islands. This refers to the heat in big cities being higher than the nearby rural areas. Heat islands are a growing problem in growing cities due to a lack of green space, a lack of wind carrying the heat, and buildings with heat-absorbing materials. Not only do heat islands cause an increase in temperature, it can also affect the mental and physical health of the residents living in it. People classified as vulnerable groups can even be affected more by it. For these groups, increased heat can even be dangerous. We want to enlighten users about this by letting them experience it in our installation, see the real-life effects, and let them know what can be done locally to help reduce this heat island effect.
Welcome to Thermopolis. When you walk into our installation, you are met with an interactable table and a virtual world around you. On the table, you can build your own neighborhood by placing the different tiles. This neighborhood is then placed in the city you select on the map. Depending on where you place different types of tiles, the existing heat map of that city will change. When you place a tile with a character on the table, you will see and experience that place of the map in multiple ways. You feel the heat and wind in that area, feel the population health, hear the population density, see the virtual surroundings change, and experience that world as if you were there.
So the design team took care of the overall looks and aesthetics of the installation. All of the 3D prints were modeled by us, and we first started by designing the assets in Blender and then figuring out a layout for each type of tile. After that, we moved on to counting all the assets, and this was sort of a tricky part because we needed to coordinate everything with the whole team and agreed on how many assets per tile and etc. We moved to the virtual environment, to Unity, and we reused the Blender assets to create a more intricate layout for the visualizations. This way the user could have more of a feeling of how it would be to be in the tile that they place. And finally, we laser cut all the elements in the panel, the heart, the map, and other assets. When we were done with laser cutting and printing, we could finally assemble everything together.
For the building, we started with the table itself, and then we added the fans, we added the lamppost with the fans, we added the shelf at the front, but we also designed the tiles itself. We laser cutted them and we made the slots so that the tiles could be placed on the table without moving all the way back and forth. And we basically made everything that needed to be attached and didn't need 3D modeling.
As hardware, we were responsible for the electronics and the equipment of the installation. The main interaction we have is the table onto which a city can be built. Each tile has a resistor inside of it, which connects to two copper washers, which form contacts with the copper washers on the table. So whenever a tile is placed, the voltage divider that's completed is able to determine the type of tile that is placed. For the city selector, the map, we can pin a little 12-volt connector into another 12-volt connector. They are reliable and they make for a good pinning sensation.
And as software, we were responsible to hooking all of this up to the system. So what we have done is we've taken the 4 Wemos devices that measure the city tiles and connected them to a Raspberry Pi, which is then connected to the server. We did the same for the map. This is also connected to its own Raspberry Pi and then also to the server. This server will then calculate the UHI, the average wind speed, and lastly, the overall health of the city.
And for my part, for the calculations for the urban heat island effect, we used formulas we found online in papers. First off, the maximum UHI component. We calculated this using parameters we gathered from datasets. These datasets are population, land use and wind speed at 100 meters. And using this, we calculated the maximum urban heat island effect for a given tile. Then, using the tile we get from the Raspberry, we can, based on its tile type, gather some parameters that we can use in the local UHI reduction. This is a formula to calculate the reduction in urban heat island effect for that specific tile. For this we use the population of the tile, the land roughness and the land use. Together, these two components create the actual urban heat island effect value for the tile. Together with all the tiles, we gather them up and send them to the window that's displayed on the beamer. This beamer then displays a heat map onto the city table. Furthermore, we send some values over to the output. This is based on the player location that the user has selected on the table.
We then use these variables and map them to be able to be used for the actual project. We map the UHI from 0 to 3 degrees increase. We map the wind from 5 meters per second to 9 meters per second. And we map the health by using an increased amount of deaths if the population were to be equal to that of the Netherlands, which would be 0 to 40.
The heat can be adjusted with a dimmable IR lamp. We do so through a DMX controller controlled by a Arduino. The fans are powered through a PWM signal. They're computer case fans. They're separately powered with a 12-volt power supply. The amount of increased deaths are represented by a backlight around the heart. So it lights up more red lights as there are more deaths. You can also feel the stress of the population by touching your hands to the heart, and it will vibrate in a simulated heartbeat.
So for our meetings, due to our group being half UT and half VU, it was quite difficult to match up. We tried a bunch of different tactics, having cameras on, having cameras off, over Zoom in one big classroom. But then when we added a standardized agenda, it started working a lot better. And then during the actual building weeks, we started having meetings daily, and sometimes that was with the whole group, sometimes that was with only the subgroup leaders, and with that way we organized our meetings.
For the video, we started filming from day one to capture every little bit of the building process. And this meant, throughout the 2 weeks, standing in the most awkward positions just to get that shot right. For the audio, we made an adaptive audio system, where every city would have their own unique sounds. This was all regulated by a population parameter. How more buildings you would have placed on the table, the higher the population parameter would be, and the more of the unique sounds each city would display, with even some cities featuring a surround sound option. The editing of the video was done all the way at the end, when we had all the footage. And now looking back at how we built the city, it's just amazing. Working with this team was such a joy. Great atmosphere, even better group dynamics, and especially in the last 2 weeks, where everyone was just concentrating on building that city. And the end result we have made is something you can truly be proud of. Such an amazing project.
Because it's really cool. Say you don't know me. Say you don't care close.
And the software we
Storyboard.